Hello, math students. Today we're going to continue talking about the measures of the angles of a polygon. Yesterday we had the formula for the sum of all of the interior angles of a polygon. So n is just however many sides we have. If we subtract 2, that tells me how many triangles I could make. And then I would multiply by 180 because each triangle has 180 degrees. So that was what we did yesterday, the sum of the interior angles. Today we're going to talk about the sum of the exterior angles of a polygon. So let's take a look at this. I've already mentioned that there are really 2 exterior angles at each vertex. But when we're talking about these, I'm only going to worry about 1 angle at each vertex because if I would draw this line out this way, I would have another one that would be exactly the same as x. I would be doubling up my total, and I don't want to do that. So I'm only going to use 1 at each vertex. The formula is, I would say, not even really a formula because it doesn't matter how many sides there are. It doesn't matter how many angles there are. Every single time, if I add up all of the exterior angles of a polygon, I get 360 degrees, no matter how many there are. So I'm going to show you this video that I have. I know it's not very big on the screen right now, but watch this. So I have this pentagon, and I keep making the sides of the pentagon smaller and smaller and smaller, but those exterior angles don't change. What I want you to know is that as those exterior angles all kind of come in closer to each other, do you notice that they make a circle? That's just adding up all of those exterior angles. And there's 360 degrees in a circle. So every single time, no matter how many sides we have, there's always going to be 360 degrees. So let's go back to this now. And let's move on. In this, I'm going to have, I want to write an equation. I've got a quadrilateral, 4 angles, 4 sides. If I would add up all of those angles on the exterior, the x and the 50 and the 127 and the 91, I would add them all up. It equals 360. So I've already crunched all those numbers. 50 plus 127 plus 91 is really 268. So then I would subtract the 268 from both sides. And that would leave me with x being equal to 92. So the measures of those exterior angles, I had the 50, I had the 127, I had the 91, and the missing angle there was 92 degrees. This one's a triangle, and it doesn't matter that it's a triangle. It doesn't matter how many sides it has. It's always going to be a sum of 360. So if I add these 3 angles together, I would have 124 plus the z angle plus the angle that's z plus 26 equals 360. And when I kind of clean that up, if I combine my z's, I get 2z. 124 and 26 is 150. And then we just solve this equation. So we would subtract the 150. And then after we do that, we will be dividing by 2. So that would give me, sorry, I didn't really leave enough space there, but the z then is 105. If the z is 105, that means this angle is just 105. We're good there. But in the other angle, I would have to do 105 plus 26. So that would be 131 degrees for both of those. This happens to be a pentagon. There's 5 sides. It looks kind of like a house that little kids draw. 3 of the exterior angles are 90-degree angles. So I really have these 2 angles that are both x's. So I can even just jump to a 2x. And then I have 3 of these 90s. That's 270 degrees. So if I would get rid of the 270, that would be 90, and x would be 45. That means that this angle is 45 degrees, and this this angle is 45 degrees. A regular polygon has congruent interior angles and congruent exterior angles. So when we talk about a regular polygon, I feel like I skipped a slide here. No, I guess not. When we talk about a regular polygon, that means that all the sides match, all the angles match, and if all the interior angles match, then all of the exterior angles also match. So instead of doing the work like we did in the last lesson, where we had to find the total of all of the angles, then divide by how many angles there are, I could do this a lot faster, knowing about exterior angles, and the sum is going to be 360. So if I have an octagon, which we know is 8 sides, I know that the exterior angle sum is 360 degrees, and I'm going to divide it by 8 to figure out how much one exterior angle will be, and I believe that's 45, but let me just check that with my handy calculator. That is 45 for the exterior angle. A decagon, deca means 10, remember, so we would have 360 divided by 10, which will be 36 degrees. 18gon, I don't have a great name for that, so we're just going to call it an 18gon, so 360 divided by 18 gives me 20 degrees for each exterior angle. Now, if I know the exterior angles, the interior angle is just the supplement of that. Now, I can do this the long way, and I'll do one of them the long way. For the octagon, the sum of the angles, remember, would be 8 minus 2, because there's 8 sides, minus 2 would tell me how many triangles I could draw, times 180. So that's really going to be 6 times 180 is 1080. That's the sum of all of the interior angles. Then I would have to take 1080 and divide it by 8 to find out one of those interior angles. So 1080 divided by 8 would be 135. That's the interior angle. Now think about what the exterior angle was. We just did that on the last slide. The exterior angle was 45 degrees. 45 plus 135 is 180. They should be supplementary. If I'm doing this kind of a problem, I don't bother finding the interior angle if it's a regular polygon. Since I know the exterior angle is 180, what I would have done is just 180 minus my exterior angle gets me my interior angle. Lots faster. The decagon, when I did 360 divided by 10, that was 36 degrees. So if I did 180 minus 36, that is 144 for each interior angle. And the 18gon, I had a 20-degree exterior angle. So I would have 180 minus 20 would be 160 for each interior angle. Remember, that only works for a regular polygon though. So today's worksheet is angles of polygons. The answer key is in Schoology, and there will be a learning check for you when you're done. If you need any help, let me know.